Many-to-many, so let's talk about many-to-many. So here we have a many-to-many relationship between student and section. Okay. Now, in relational databases, there's only really one way that we can implement many-to-many relationships, right? There has to be a mapping table in between that has foreign keys to both of the original tables, to the other records. That's really the only way to implement that. Okay. In a class diagram, if you have a many-to-many, you have to reify it, right? So that you have the foreign keys that can be implemented in a relational database. Well, it just so happens that in a non-relational database, we don't really need to reify. Okay? We can actually implement the original intent of the class diagram. The original intent of the class diagram is that a particular instance of a student has many sections. Right? It's related to many sections. Right? But because relational databases don't have arrays, the only way to implement that was to have an additional artificial table that was not originally documented in the UML diagram. Okay? So students might have an array of sections, and sections might have an array of students. Right? That is the original intent. Now, additionally, you might have here association classes that create a three-way relationship between students, enrollments, and sections, where the way to implement that in a relational database is to have same way as you would have it as a mapping table, right? Foreign keys back to the original tables, plus any additional fields that might describe that relationship. Okay? In that case, we do have almost a one-to-one relationship of what to implement, what to document in a UML diagram, and what you actually implement in a relational database. Right? But a simple mapping of many-to-many without an association, right, would have been just an array and an array. Right? And we can actually implement that in Mongo, right, because we can have arrays. So let's consider all three ways of all different ways of implementing this many-to-many relationship. One of the ways to implement it is to have an actual element collection that has references to both the student and the section documents. Right? That's certainly the classical way of implementing it. It's the only way of implementing it in a relational database. Right? But here too, we have the option of doing what we've been doing so far, right, in a relational database, right? You would have a record or document in an enrollment one document having a field section having the value of the ID of some section, of some other section object. And it could have a student property whose value is the ID of some student record. Right? So this is the classical way of implementing it, right? You have two foreign keys referencing some other documents. But that's not the only way of implementing. Now, because we can have a much richer set of structures here, we can actually have a field. Each one of these, the student one and student two, and the sections can actually know about each other, right? We can have the student have an array of sections that they are enrolled in. Right? For instance, you have student one subsections, and then list all the sections that the student is enrolled in. But that introduces a conundrum, right? It says, wait a minute. So, is the many-to-many a two-way relationship where you would want to navigate backwards and forwards, right? From the students go to the sections, and from the sections come back to the students. Right? Is that a use case in the actual implementation? Is that a requirement in the application that you can navigate backwards and forwards? If not, I'd rather not. Because notice what complication we introduce here. If both the students knows about the sections and the sections know about the students, now we have redundancy, right? Because if the student knows what sections they're in, right, I would need to capture that also in the sections. Right? It would make no sense if I ask the students about the sections and it tells me something. If I ask the sections about the students and it tells me something else, right? It would be inconsistent, yes? And that's why we try to avoid redundancy. because we don't want to run into these types of inconsistency that depending on how you query, you get two different answers. Right? So if you go with this implementation, you run into the additional administrative task of making sure that these two things are in sync. Right? That if one section is listed in somebody's student, then that student needs to be listed in that section's students. Right? They have to match. So ideally, we would not do this. Right? We would prefer not to do this. So graphically, this is the classical way, where the enrollment points to the records or the documents of student and section. Obviously, we would need to do some mechanism of joining things together. And so this is kind of an edge case of saying, wait a minute, I don't really want to join because Mongo in non-relational databases doesn't really support joining, right? And that's really not its forte. But neither do I want to do something like this, where the students references to all the sections that they live in, that they are enrolled in, like student 1 and student 2, they're both enrolled in section 1. So that means that section 1, right, better have those two students in its students elements, so they can point back to the students, right? So you have a two-way pointing, right? So we have the students referencing the sections, but then the sections referencing back from the students. It would be inconsistent that you wouldn't have both. So typically, you would try to avoid this, right? The developer probably will go back to the business analyst, will go back to the client, and make sure that the use case must be supported. In this case, we need to support it, right? It makes sense that a student, it's very common that a student wants to know the sections that they're enrolled in. That makes sense. And from the administration's point of view, they want to be able to look at the sections and look at all the students that are enrolled in. Right, that all the students that are enrolled in that section from the faculty's point of view. So yes, both use cases make sense. So you would be left with the decision of whether to go with one implementation or the other. Okay. Now, if you have a way to automate this, this would be the preferred way of doing it. If you don't have a way to operate and you're doing this manually yourself, this would be a preferred way of doing it. Okay, so if you have a library that does this automatically for you, right? Sometimes referred to as managed redundancy. Right, managed redundancy. So it's okay to have redundancy as long as you don't have to manage it. Right. So for that, for instance, you would use views or materialized views, right? That would allow you to have the redundancy, right? But it's not a real table. It's a view. It's a materialized view. Okay, so how would you implement it? If you're using this implementation, you would have an enrollment collection, and you would insert in there a JSON object that references the section and references the student. And notice that it's the ID of the student and the ID of the section, which you can use to retrieve the original student or retrieve the original section. Yes? To do the join, even though joins are not supported. But if you know the ID, you can always retrieve that section and that student. To implement the two-way referencing, the way to implement it would be, from the student's point of view, you would update the student, make sure that you initialize an array of sections. Here it is, right? I'm setting a brand new field called sections, and the initial value of that array, here's the initial value of the array, my very first section that I just enrolled in. See that? If I am going to enroll a new section, I need to push a new section in here. Yes? Right? And Mongo supports that. There it is, $push. Right, so $push allows you to take a look at an existing array and push a new value into that array. Right? Pretty cool. Okay. But if now the student knows about the two sections that they're enrolled in, the section also needs to know about the students that are enrolled in that section. So you cannot, after you've done this, you cannot forget to do this part, right? Where the section says, I know there's a student enrolled in this section, so I need to add an array of that particular student that just enrolled, right? And then push the new student that just enrolled. So now I know all the students that are enrolled in that section. We had to do something similar in Java, remember? Right? Because in SQL, it's natural that you can navigate backwards and forwards between one table and the other table, right? Because it's just a join, right? You just make two fields equal, right? Where the primary key of one of them is equal to the foreign key of another record, and it allows you to just retrieve fields from both sides. Yes, it's a natural thing. In Java, it's not as natural, right? In Java, typically it starts from a parent having an embedded child, and usually the child does not have a reference back to the parent, right? We implemented it. We implemented it because, well, we wanted to provide the same features that SQL provided, being able to navigate backwards and forwards between the two data types, right? And we had to go through this, right? Remember we said, I think what we did is add a course to an author, or something like that, right? And then, well, if an author knows about a course, then the course needs to know about the author. Remember that? And checked, and there were the setters were written in such a way to make sure that the reference already existed. If it didn't exist, then add it. Okay, so similar thing here, right? To know about each other. All right, so let's look at one-to-many.